I want you to start by picturing just a really mundane chore that we all do pretty much every single day.
Oh, like washing the dishes.
Yeah, exactly. So you're standing at the kitchen sink and you're facing down this greasy, heavily used frying pan from dinner.
Right.
You grab a bottle of dish soap and you squirt a really generous amount directly into the center of that congealed mess. And I mean, we all know the immediate visual,
Oh,
right?
yeah, it just immediately breaks apart.
Exactly. The soap aggressively attacks the grease.
Uh,
Through the chemical properties of surfactants, it actively dissolves that thick, stubborn layer of oil. It breaks the molecular bonds and strips it completely off the surface of the metal so the water can just easily wash it away.
it's an incredibly efficient reaction.
It is. It's efficient and honestly slightly violent when you think about the chemistry. Now, I want you to hold on to that exact visual. Imagine that exact same chemical process, that highly efficient stripping away of a protective lipid-based layer happening right inside your own digestive tract.
It is a vivid image to kick things off with,
Yeah.
but it sets the perfect mechanical foundation for the biology we're examining today. Because when you look at the fundamental chemistry of digestion, the mechanics of how we process external substances, they don't just magically change because the chemical in question happens to be edible.
Right.
It really forces a complete reevaluation of the everyday, invisible chemical interactions happening inside the human body.
Welcome to today's deep dive. Our source material today is a really detailed, fascinating breakdown from a YouTube video by Dr. Eric Berg, DC. And the mission for this deep dive is to uncover a specific, highly industrial category of ingredients that is currently engineered into roughly 60% of all packaged grocery store foods.
60%. It's just a staggering number.
It really is. So we are going to examine the physiological reasons why these ingredients act exactly like that harsh dish soap inside the human gut, the downstream metabolic consequences of that reaction, and most importantly, figure out what we can actually do about it.
Okay, let's unpack this.
Mm.
Because the sheer volume of places this hidden ingredient lives is, well, it's everywhere.
Yeah, the ubiquity is perhaps the most critical factor here. We aren't just discussing hyper-palatable junk food. You know, if this were only a matter of avoiding neon-colored candies or deep-fried snacks, the public health conversation would be so much simpler.
So much simpler.
But the reality is far more integrated into our standard daily consumption.
Right, because according to the source material, we are certainly talking about things like ice cream and chocolate bars.
Yeah.
But this category of ingredients is also a total staple in salad dressings. It's heavily utilized in supposedly health-conscious plant-based milks.
You will find it in the commercial bread you use for your sandwiches, inside fitness-marketed protein bars, blended into peanut butter, stabilizing your morning coffee creamer, mixed into mayonnaise, and this is the one that really got me. It's a standard ingredient in baby formula.
Which demonstrates that this is an industrial manufacturing standard, not a culinary choice. To understand why manufacturers rely so heavily on these compounds, which are collectively known as emulsifiers, you have to look at the logistical challenges of mass-producing food.
The chemistry of creaminess, basically.
Exactly. In chemistry, lipids and water are fundamentally incompatible. They naturally repel each other and separate over time. But in the commercial food industry, separation is a catastrophic failure. If a product separates on the shelf, consumers just won't buy it.
Nobody wants separated salad dressing.
Right. So emulsifiers solve this problem at the molecular level. Their sole chemical function in food is to force oil and water to mix. They are amphiphilic compounds, meaning they possess both a hydrophilic or water-loving end and a lipophilic or fat-loving end.
They act as the chemical bridge.
Exactly.
By binding to both the water molecules and the fat molecules simultaneously, they force these totally incompatible substances to remain suspended together indefinitely. This is what makes a processed salad dressing look perfectly uniform. It's what gives commercial ice cream that incredibly smooth, creamy mouthfeel, and crucially for the manufacturers, it dramatically extends the shelf life.
And that stabilization is their sole purpose. They offer absolutely zero nutritional value to the human body.
None at all.
The human body doesn't recognize them as fuel. They are simply structural engineering tools for the food matrix.
And to put some specific names to these engineering tools so you know exactly what to look for on the ingredient panels, Dr. Berg reels off several of the most prevalent offenders. You're looking for terms like polysorbate 80, mono and diglycerides, carboxymethylcellulose, and carrageenan.
Those are the big ones.
Yeah, and these are highly synthesized compounds. Carboxymethylcellulose, for example, is a cellulose derivative, often synthesized using chloroacetic acid. I mean, it's a brilliant feat of chemical engineering for shelf stability, but it presents a really unique physiological challenge once you actually eat it.
What's fascinating here is the central metaphor Dr. Berg uses regarding that chemical durability, because the inherent nature of an emulsifier is to dissolve and breach the boundaries between fat and water. The issue is that this chemical function does not magically deactivate the moment it passes your esophagus.
It keeps working.
It remains a chemically active surfactant as it moves through your stomach and into your intestines. And that continued mechanical action creates a severe conflict with our internal anatomy.
Because it directly targets the mucus layer. The human gut is lined with this highly specialized, thick layer of mucus. And this isn't just a static coating, it is a dynamic, protective border wall built out of mucin
It's
proteins.
this highly guarded border.
Yes, exactly. On the outer side of this wall, inside the hollow tube of your intestines, you have the chaotic environment of digestion. Trillions of live microbiome bacteria, digestive acids, breaking down food particles. But on the inner side of that thin, highly guarded mucus wall is a single layer of epithelial cells. And directly behind those cells is your bloodstream and your immune system.
And that physical separation is totally non-negotiable for human health. That mucus barrier is the only buffer preventing the massive bacterial load of your digestive tract from entering your highly sensitive systemic circulation.
So what happens when that mucus barrier is actively thinned out by these daily emulsifiers?
Well, because emulsifiers are specifically engineered to dissolve structural boundaries and bind to lipids and proteins, they actively interact with the mucin proteins in that protective layer. They thin it out. They disrupt the gel-like structure of the mucus, acting just like that dish soap on the greasy pan you mentioned earlier.
Wow.
They are put into the food to emulsify the ingredients, but they end up emulsifying your own biological defense systems.
That is wild. The structural degradation of that barrier brings us to the mechanics of intestinal permeability, which is commonly referred to as leaky gut. When that mucus layer is thinned out, the tight junctions between the epithelial cells lining the gut literally begin to loosen and separate. The biological border wall is breached.
Right, the gates are open.
Suddenly, microscopic entities that were meant to remain strictly inside the digestive tube begin to leak through the intestinal wall. We are talking about live bacteria, toxins, specifically lipopolysaccharides, which are endotoxins produced by certain bacteria, and large, partially digested protein molecules from your food that were never supposed to cross over. They slip through those compromised junctions and diffuse directly into your bloodstream.
And when those stray proteins and bacterial endotoxins arrive in the systemic circulation, the body's defense mechanisms are forced to engage. The majority of your immune system is actually stationed right there, nestled in the gut-associated lymphoid tissue just beneath the intestinal lining, actively surveilling the perimeter.
Just waiting for a breach.
Exactly. So when immune cells encounter these leaked particles in the blood, they do not recognize them as beneficial nutrients, they flag them as foreign invaders. The immune system tags these molecules as pathogens and mounts a defensive attack.
So, what does this all mean for the person actually eating this food? The immediate consequence of that immune response isn't necessarily a sharp, localized pain that sends you to the emergency room, right?
Usually not.
Instead, the continuous leaking of these particles triggers the release of inflammatory cytokines, creating a state of low-grade, chronic, simmering systemic inflammation.
And that simmering inflammation is highly insidious. If you are consuming emulsifier-laden foods multiple times a day, the coffee creamer in the morning, the sandwich bread at lunch, the dressing at dinner, you are maintaining a constant state of immune alarm. Over years and decades, that chronic inflammatory response actually damages the cellular architecture of the colon.
Dr. Berg mentioned scar tissue, right?
Yes. The body attempts to heal the continuous damage by laying down physical scar tissue. And once the delicate microvilli of the gut lining are replaced or obscured by fibrous scar tissue, the primary function of the gut, which is absorbing nutrients, is severely compromised. You could be eating the most nutrient-dense vegetables on the planet, but if your gut lining is scarred, your body physically cannot extract and absorb those vitamins and minerals efficiently.
And the downstream systemic consequences of this continuous immune activation extend far beyond localized digestive discomfort. Dr. Berg highlights a whole cascade of symptoms that many people might never connect back to their gut health.
It's all connected.
It really is. When you have chronic inflammation originating in the intestines, inflammatory markers circulate systemically, eventually crossing the blood-brain barrier. This manifests clinically as brain fog, that heavy, sluggish cognitive sensation where you simply cannot focus or think clearly, particularly after eating.
A very common complaint.
Absolutely. Furthermore, this compromised lining leads to sudden, inexplicable food sensitivities. People often find that whole, healthy foods they have eaten their entire lives suddenly trigger severe bloating or fatigue. The food itself hasn't changed. The physical integrity of the individual's digestive tract has been completely undermined by the daily intake of these detergent-like additives.
It alters the baseline mechanics of how human biology interacts with its environment. And when you have a mechanism this disruptive, it really requires a close examination of the empirical data. We have to look at the scientific evidence demonstrating that these specific synthetic compounds are responsible for this level of biological degradation.
The source material provides a very upfront look at the available data. Dr. Berg admits that we do not have perfect, decades-long, randomized, double-blind human clinical trials tracking the minute-by-minute degradation of the gut lining due to a specific emulsifier.
Such a study would be nearly impossible to conduct logistically.
Exactly. However, the existing animal models provide a highly detailed mechanistic view, particularly concerning polysorbate 80. When researchers administer polysorbate 80 to mice, the physiological changes are aggressive and rapid. The mice develop full-blown metabolic syndrome.
It's dramatic.
Very. They exhibit rapid weight gain, severe dysregulation of their blood sugar levels, and profound alterations in the composition of their gut microbiome. The chemical surfactant fundamentally dismantles their metabolic stability.
The animal data establishes the biological mechanism beautifully, showing exactly how the chemical alters gut bacteria and drives metabolic dysfunction. But the translational data moving from mice to men is where the conversation becomes incredibly urgent.
Here's where it gets really interesting.
Wow.
We don't just have to rely on the mouse models anymore. The source brings up a rigorously controlled human trial published just recently in 2024, and this study didn't look at decades of exposure. It focused entirely on short-term, acute exposure to common dietary emulsifiers.
Yes, the 2024 trial data is a critical inflection point in our understanding of food additives.
The timeline of the physiological changes observed in these human participants is truly shocking.
It is. The researchers found that human subjects who consumed a diet containing common emulsifiers experienced measurable, significant alterations to their gut microbiomes in just 14 days. 2 weeks of exposure was enough to fundamentally change the bacterial ecosystem.
14 days to alter the microbiome.
And even more concerning than the shift in bacterial species was the spatial alteration. The study observed that the bacteria physically migrated closer to the intestinal epithelial lining.
The physical migration of the bacteria implies that the spatial buffer, that sterile inner layer of mucin proteins, was actively being dissolved. The protective border was washed away, allowing the microbiome to encroach directly upon the sensitive cellular lining of gut, all within a 14-day window.
Right.
When you scale that 2-week reaction across an entire lifetime of consuming ultra-processed foods, the cumulative impact is just massive.
If we connect this to the bigger picture, the epidemiological trends over the last few decades align perfectly with this biological mechanism. Dr. Berg points out the staggering correlations. Diagnoses of irritable bowel syndrome, or IBS, have essentially doubled in the last 20 years.
Doubled.
Concurrently, the rates of autoimmune diseases are skyrocketing. And the medical community widely acknowledges that a significant percentage of immune system dysregulation originates right there in the gut-associated lymphoid tissue.
And these massive spikes in chronic gut dysfunction and autoimmune conditions are highly concentrated in populations that have adopted ultra-processed, industrially manufactured foods as the foundation of their daily diets. The correlation is impossible to ignore. We have an ingredient that causes metabolic syndrome in animal models, human trials demonstrating rapid microbiome degradation in just 2 weeks, and population-wide explosions in gut-related diseases.
It paints a very clear picture.
It does. Which brings us to the regulatory framework. How on earth are these actively disruptive chemical compounds legally permitted to be in 60% of the packaged food supply?
The answer lies in a specific historical regulatory loophole in the United States, which the source details. It is known by the acronym GRAS, which stands for Generally Recognized as Safe.
The phrasing generally recognized as safe projects this sense of comprehensive scientific consensus and rigorous government oversight. But the actual legal mechanics of the GRAS designation operate very differently, don't they?
Very differently. The GRA's provision was originally established decades ago to cover common traditional food ingredients like salt, vinegar, and baking powder, so they wouldn't have to undergo the same rigorous pre-market approval as entirely new synthetic chemicals.
Which makes sense for salt.
Right. However, the food industry has utilized this provision as a massive self-regulation loophole.
Hmm.
Under the current interpretation of GRAs, food manufacturers are legally permitted to self-certify their own novel chemical ingredients as safe for human consumption.
Wait, they self-certify?
Yes. The self-certification aspect fundamentally alters the safety landscape. Companies are not legally mandated to subject these novel polymers and synthetic emulsifiers to independent, third-party, long-term safety trials before introducing them into the food matrix.
That is wild.
They are not required to provide the FDA with extensive human trial data demonstrating what happens to the gut microbiome under conditions of chronic, daily exposure. The burden of proof for long-term physiological safety is essentially bypassed.
Because the initial safety data that did exist for many of these emulsifiers was largely based on short-term acute toxicity studies conducted decades ago, the regulatory threshold was incredibly low. Regulators essentially asked if the immediate ingestion of the chemical resulted in acute poisoning or lethal toxicity.
Does it poison you immediately? No.
Right.
Okay, it's safe.
Exactly. Because these emulsifiers do not cause immediate catastrophic organ failure upon swallowing, they were granted the GRAS designation. The regulatory bodies entirely missed the far more complex biological question. What is the cumulative effect of a human being consuming these low-level chemical surfactants 3 to 5 times a day, every single day, for 30 years?
And that failure to account for chronic long-term degradation is what's driving the current reevaluation of our food safety standards.
The source material actually wades into the political sphere a bit here, specifically mentioning Dr. Berg's hope that politician RFK Jr. will eliminate this GRAS loophole entirely.
Right, and taking a completely neutral look at that, regardless of individual political affiliations, the fact that this specific regulatory mechanism is being targeted on a national stage really highlights a broader, growing public scrutiny. There is a mounting consensus across various demographics that the mid-century regulatory framework governing food additives is just structurally inadequate for overseeing the complex, highly engineered modern food supply.
The inadequacy of that oversight becomes incredibly stark when you consider the demographics most affected by these compounds, because the most vulnerable population, the ones enduring the highest volumetric exposure to ultra-processed foods, is children.
The developmental implications there are profound. A child's microbiome is actively establishing its baseline diversity and strength during the first few years of life. Introducing powerful chemical surfactants during this critical window disrupts the foundational architecture of their immune system and metabolic regulation.
The source material is quite definitive about the timeline of this exposure. It begins almost immediately. We mentioned it earlier, but a significant portion of commercial infant formula relies on these emulsifiers to maintain its suspension and shelf life. Dr. Berg highlights that due to these synthetic additives, many infant formulas structurally resemble highly processed industrial products.
Sets a concerning baseline.
And as children transition to solid foods, the exposure only compounds. The standard modern diet for a child heavily features items like commercially baked bread, bowls of shelf-stable cereal, crackers and granola bars for school snacks, boxed macaroni and cheese, chicken nuggets, ice cream. Every single one of these staples relies on emulsifiers.
From infancy through adolescence, their developing digestive tracts are continuously processing these chemical agents. They are completely bypassing the opportunity to build a robust, uncompromised mucosal barrier.
So we have this massive systemic issue.
This raises an important question. In a modern society where these compounds are legally sanctioned, hidden behind complex chemical nomenclature on ingredient panels, and physically present in 60% of all packaged goods, how does an individual practically navigate this landscape? How do we actually avoid these chemicals?
The instinct might be to become a hyper-vigilant consumer, spending hours in the grocery store reading every ingredient list, cross-referencing every single label. But Dr. Berg offers a surprisingly simple, structurally sound solution. His advice bypasses the need for an advanced degree in chemistry or endless willpower. His core strategy is simple. Don't rely on sheer willpower. Just don't buy ultra-processed foods and absolutely do not keep them in the house.
Shifting the strategy from disciplined restriction to environmental design is incredibly effective from a behavioral psychology standpoint.
To make it really relatable, Dr. Berg shares a highly personal confession from the video, his own addiction to potato chips.
I love this part.
It's so honest. Despite possessing a deep, comprehensive understanding of the metabolic damage ultra-processed foods cause, he acknowledges his own human nature. He has an agreement with his wife to never keep them in the house. He knows unequivocally that if he is exhausted late at night and those chips are accessible in the cupboard, his willpower will collapse and he will eat them.
The neuroscience behind that anecdote is rock solid. Willpower is not a permanent character trait. It is a finite cognitive resource subject to severe decision fatigue. As you navigate the stresses of a given day, your prefrontal cortex, the area of the brain responsible for impulse control, becomes depleted.
So by 10 p.m., you have no defenses left.
Exactly. When you are tired, stressed, or emotionally drained late at night, your brain's biological imperative shifts towards seeking the most calorically dense, highly palatable, and easily accessible energy source available. If that emulsifier-heavy processed food is sitting just a few feet away in your kitchen, the biological drive will almost always override the intellectual understanding of the health risks.
But conversely, if you implement strict environmental curation and refuse to let those products cross the threshold of your home, you completely change the equation. When decision fatigue sets in at 10 o'clock at night, your brain evaluates the available options. If the processed snacks are not in the house, the effort required to obtain them, putting on shoes, finding the car keys, driving to a store creates way too much friction.
The biological drive for easy calories is interrupted by the logistical difficulty. You are far more likely to simply grab an apple from the fridge or just go to sleep.
By aggressively curating your immediate environment, you eliminate the daily psychological battle. You make the protection of your gut lining the default effortless outcome.
It is a profound shift in perspective. You are no longer restricting yourself. You are structurally engineering your environment to support your biological integrity. You ensure that the only options available are whole, single-ingredient foods that require no chemical stabilization.
It is a highly actionable strategy to combat a deeply systemic issue. To synthesize the complex journey of this deep dive, we started with the visceral image of dish soap stripping grease from a pan and applied that exact chemistry directly to the mucin proteins protecting our intestinal lining. We examined the biological fallout of that mechanical degradation, tracing how the thinning of the mucus barrier leads directly to leaky gut, allowing bacterial endotoxins to trigger a chronic systemic immune response.
We reviewed the compelling animal data and the alarming 2024 human trials,
demonstrating how quickly these chemical emulsifiers alter our internal bacterial ecosystems. We unpacked the current reality of the GRAS regulatory loophole, which currently leaves it up to consumers to protect their own pantries. And finally, we explored the behavioral strategy of environmental design, the realization that the most effective way to protect our metabolic health is to simply stop letting industrial chemistry through our front doors.
It is a comprehensive reevaluation of the modern food matrix. But to leave you with a final thought to mull over, I want to return to a brief, highly optimistic point teased at the very end of the source material. The source emphasizes that the human microbiome physically alters and degrades in just 14 days of exposure to these industrial emulsifiers. But Dr. Berg explicitly notes that there are very real, actionable ways to correct and repair the cellular damage once the offending agents are removed. It leaves you wondering, if a simple, ubiquitous chemical additive can dismantle our body's highly evolved built-in defense system so incredibly fast, how rapidly could our biology reconstruct and heal itself if we completely remove these modern conveniences from our environment? In the face of industrial chemistry, are our bodies incredibly fragile or secretly incredibly resilient?
That is a remarkable question to carry forward, and it completely reframes the potential for our own health. Thank you for joining us on this deep dive. Keep examining the structures around you, keep actively curating your environment, and above all, keep questioning what fuels your body. Catch you next time.